So let's take a look at this worksheet, and we're going to explain the even ones on this video. You want to determine whether each relation is a function. So is the machine working or is it broken? Now think about this one. We're talking about the machine. You plug in one number, you get out one answer. You plug in one number, you get out one answer. You plug in one number, you get out one answer. You plug in a number, get out one answer. You never plug in the same number twice and get out different answers, do you? Right? So this one, it passes. It is a function. It is a machine. So F, function. Or in the back it says yes. Yes, it is a function. Right? Now, I know we're doing the even ones only, but might as well compare this one with number 3. Number 3 is not a function. It's just a relation. Why is that? Because the input 4 gave you a 2 as an output, and then the input 4 gave you a 5 as an output. You see, it gave you 2 separate outputs for that one single input. That the machine's broken. I mean, think about it. We've been dealing with functions, and remember when we made an XY table, we would plug in 0, plug in 1, plug in 2. Whenever you plug in different numbers, you get out single answers. But if you ever plug in the same number 2 times, you're supposed to get out the same answer. And right here, you plugged in a 4, you got out a 2. You plugged in a 4, you got out a 5. That's broken. That's no longer a function. That's just a relation. Okay. Let's go to number 4, since we're doing the even ones. What do you guys say? Is this a machine that works, which we call a function machine, or is it broken and call it a relation? It works. Absolutely. Function. So F for number 4, or you could write out the word function. Or in the back it says yes, as in yes, it is a function. How do you know it's a function? Because you never plug in the same number twice. Now, if I would have had a -1 as another example, and then I get out a -11, then that would be a broken machine. Why? Because -1 gave me a -10. If I plug in a -1 again, it better give me a -10, and it didn't. Right? So that would be a broken machine. That would be a relation. But of course, that's only because I added this, so that didn't belong to the original question. Do we get it? Yeah. Moving on, number 6. That is definitely a broken machine. That's what we call a relation. What makes it a relation? The 3 gave me a 7. If I plug in a 3 again, it better give me a 7 again, and it doesn't. It gives me a 5, right? Now, what are all of these guys? They're all coordinates, right? So imagine if I did graph the coordinate on an XY plane, these coordinates, if I graphed 3, 7, 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, it would be right there. And this coordinate would be 3, 5, 3, 1, 2, 3, 4, 5, it would be right there. What do you notice about these 2 dots? They're perfectly right on top of each other, right? So this is just to show you how it relates to the vertical line test. It would fail the vertical line test, right? So we're going to be able to look at it visually with the vertical line, and if you ever have 2 dots on the same line, then it fails the vertical line test, which means it's not a function machine, it's just a relation. Or you could simply think, oh, I plugged in a 3, I got out a 7, I plug in a 3, I got out a 5, that's broken. So this is definitely a relation. Move on to number 8. Some of us are thinking, what the heck? Number 8, there's no graph, there's no table, we just have a bunch of coordinates. We need to remember that coordinates are really x and y values. And x and y values are really input and output values. In other words, my 6 is my input, my -1 is my output. So think about that in the machine. You plugged in a 6, you got out a -1. You plugged in a -4, you got out a 2. You plugged in a 5, you got out a 2. You plugged in a 4, you got out a 6. You plug in a 6 again, and you're supposed to get out a -1 again, but this time you plugged in a 6 and you got something totally different for the y, which was a 5. So this is definitely not a working machine. It's not functioning right? It's not a function, it's just a relation. So number 8 is just an R, relation. What do you think? Number 10. Now number 10, actually 9 and 10, people get confused. Why? Because these are just regular equations. I don't give you an XY table. I don't give you coordinates. But if you ever have a function like number 9 and you want some coordinates, what could you do? Yeah, you could make an XY table, an input-output table, and plug in some numbers, right? Oh, wait a minute, we're not supposed to do number 9. Let's go to number 10. I mean, on this video, I'm doing the even ones. You guys have to do all of them, but I'll do another video with the odd ones. So number 10, we don't have coordinates, but we could get some coordinates by making an XY table. And this one's so easy that students get confused. What do I mean by that? If you do 0, 1, and 2, you're going to plug in 0 where? There is no x, right? In other words, x is not there. X doesn't matter. The only thing that this equation cares about is that your y values are equal to 11. So on your y side over here, you're going to put 11 3 times. 11, 11, 11. I mean, you have an infinite amount of coordinates, but if you think about these coordinates, do any of them line up vertically on top of each other? No. That's going to give you a perfectly flat line, right? So, or you could even think of it numerically. I plugged in a 0, I got out an 11. Plugged in a 1, got out an 11. Plugged in a 2, got out an 11. Is there any way I could plug in the same number, 2 again, and get out a different answer? No, because this equation says your y has to be 11. So this is definitely a function. Make sense? I hope. Jumping to number 12, we can use the vertical line test on this one. And again, you just want to make sure that your dot, there's only one dot on the vertical line at a time. So there's one dot there. So far, it's passing the vertical line test. Yes, it's a function so far. Yes, it's a function so far. Problem, right here, it's not a function. Why not? Because you have 2 outputs for the given input. In other words, there's 2 dots on that vertical line. So if it touches the vertical line at more than one spot, then you know it fails the vertical line test. It's not a function. It's just a relation. Now, if you still don't get it, you could think of the coordinates, guys. Like, what is this coordinate right here? That coordinate is 2, 2. For my input 2, I get the output 2. And this coordinate right here, it's the same input 2, but this time you get out a -1. So numerically, you could also say that this is a relation. It's a broken machine. It's not a function. Let's jump to number 14. So number 14, the notation, all it is, it's telling you which one to use. Are we using the F or the G? We're using the F, obviously. Now, what is the difference between this notation and this? This has f of x, and right here, visually, the 4 replaces the x. So what this is saying is to take your f of x function and plug in 4 right into it. Now, I always recommend rewrite your function, but with parentheses instead of the x. So let's put 3x plus 2. And what are we plugging in to the parentheses? What you see in parentheses right here, the 4. So plug in the 4 right into the parentheses. 3 times 4 is 12. 12 plus 2 is 14. You see, it's easy. So let's move on to number 16. So let's go to 16. And f of x is the function that we're using. So let's rewrite f of x, which is 3x plus 2. But instead of x, let's put parentheses. So I'm going to write 3 parentheses plus 2. 3 parentheses plus 2. There is my f of x function. And what am I going to put inside the parentheses? That -2. It's going to go right inside of the parentheses. Just like it's inside of the parentheses here, you put it right in the parentheses there. Then, of course, you do the math. PEMDAS. Multiply first. 3 times -2 is -6. Bring down plus 2. -6 plus 2 is -4. You see, it's easy. Let's go to 18. 18, on the other hand, is the G function. So you're not going to be using the F. You're going to use the G. And the G says x squared minus x. So again, g of x is really x squared minus x. What am I going to write? I'm going to write parentheses squared minus parentheses. Again, parentheses squared minus parentheses. So let me write down parentheses squared minus parentheses. And let me plug in the value that they're telling me to. It's saying g of -3. They want us to plug in -3 into the parentheses. So you're going to use PEMDAS to simplify this thing. 3 squared is +9. -3 times -3 is +9. And then the -3 changes to +3. So that's really 9 plus 3, which is 12. number 20. So 20, it's telling us f of 2. That tells us to do something. That notation is telling us to go to the f of x function and plug in 2. We're going to do that, and once we get an answer at the very end, we're going to add 1. Okay? So let's go f of x. F of x is 3x plus 2. So what I'm going to write is 3 parentheses plus 2. So put 3 parentheses plus 2. That's f of x. And what do they want us to do? They want us to plug in 2. So you plug in 2. Okay, now this plus 1, I'm going to wait till the end. Okay, I'm just doing this part right here, the f of 2. So 3 times 2, that's 6. 6 plus 2 is 8. And now I'm going to take the plus 1 and add it to my answer. 8 plus 1 is 9.
Wait, that's all?
That's all. And if you check the answer in the back, you should see 9 right on the answer there. Number 22. It's easier if we just write down the g of x function. G of x is x squared minus x. And what they want us to do first is g of 2. That tells you to do something. What does it tell you to do? To go to your g of x function and plug in 2 and simplify it. So we're going to rewrite the g of x function, but with parentheses instead of these x's. So I'm going to put parentheses squared minus parentheses. And that's so far the g of 2 right here. I'm going to wait for the minus 2 till the very end. So I am actually going to be plugging in the 2 into my parentheses. There's 2 right there, 2 right there. And let's do the math. 2 squared, that's 4. And 4 take away 2 is 2. So my g of 2 really ended up equaling 2. But then I have to take away 2 from it. So I'm going to get this minus 2, and I'm going to bring it right down, and there's a minus 2 right there. So finally you have 2 take away 2, which is 0 as your final answer on number 22. Let's go to number 24. So on 24, I just jotted down the f of x function right above it. And this is telling us to go to the f of x function and plug in this value that you have inside parentheses, and you plug it inside parentheses. So if you had a 5 right here, you would plug in a 5 in parentheses where the x is at. If you had a negative 3 right here, you'd plug in a negative 3 in parentheses where the x is at. But you don't have a number, you have a binomial x plus 1. You're going to have to actually plug in this x plus 1 inside that x spot, but with parentheses. So the first thing to do is to rewrite your f of x function 3 parentheses instead of 3x plus 2. And then you plug in the value that's inside the parentheses, which is a x plus 1. Then after that, you simplify. So you're going to distribute and combine like terms. 3 times x is 3x. 3 times 1 is 3. Let's not forget about the plus 2 that's out there at the end. After distributing, try to combine like terms. You have a plus 3 and a plus 2. That ends up being a positive 5. So 3x plus 5 is your final answer, your final algebraic expression for number 24. So I believe that's about it for the even questions. I'll make a video explaining the odd ones later.